Give me a sec.
So today we start section 2, and section 2 is adding and subtracting these polynomials. Okay? And so we're going to have some different definitions and terms that you're going to need to know. And I'm going to go over these really slowly so that you get them all. And can someone remind me what time this period is? Because I forget about the chapel.
10 o'clock.
10 o'clock even? It's after 10 now. Or is that clock wrong?
That
Yeah,
clock's
that
backwards.
Oh,
No,
the clocks aren't
no,
working.
it's ahead by an hour.
I'm the smart boy, then it's 10 o'clock.
9:04. So we got 20 minutes. Okay, just checking. All right. A monomial. Got to write this down there. Got to write these down. You're not going to know them. I'm telling you guys. You'll forget. A monomial is an expression that is either a numeral. A numeral is just a number. Or a variable. Variable is just anything that can stand for something else. X, N, L, Q, P, R, whatever it is. Doesn't matter. Or the product of a numeral and one or more variables. So an example of a monomial might be 3. That can be a monomial. Or X. Or 7y, because that's a product. Okay. Or negative 4xyz. Okay, so it can be any of those. It can be any number, any variable, or the product of a numeral and one or more variables. Okay, that's a monomial. A numeral is called a constant monomial or a constant. And I think I alluded to this yesterday because I think I called it that when we started going over this section. Okay, so if there's not a variable, if it's just a numeral, it's called a constant or a constant monomial, but typically we just call it a constant. Okay. The sum of monomials is called a polynomial. Notice that the word monomial, it comes from the Greek mono meaning one. Okay? Poly meaning many or more than one. Okay? So if you remember that, I don't think you will, but if you do remember that, then you will be on your way to knowing what that is. Now, a polynomial can have just 2 terms. So any of these monomials separated by the addition sign is a polynomial. So, for example, 3 plus, I'll just add those up there, x plus 7y minus 4xyz. That's a polynomial. You have 4 monomials. Notice that when I have this minus, what is that really? That's just really 3 plus x plus 7y plus negative 4xyz. Okay, so even though when you have a minus sign, it's really you're adding the opposite, so that's also a polynomial. Okay, in this one, how many terms are there? Or how many monomials are there? Elise, in this one here, or this one here that I wrote, how many monomials are there? No. Well, they're separated by the plus sign. So 1, 2, 3, 4. So there's 4 monomials in this polynomial. Okay? We call these monomials in a polynomial, we call them terms. So if you hear the word terms, and I believe I put that up. If you have a polynomial with 2 terms, we call it a binomial. Binomial, bi meaning 2. That's what the prefix bi means, is 2. And so, give me an example of a binomial, Weston. Anyone at all? I'll write it down.
7y.
That's a monomial. Give me a binomial.
7xy.
I'm sorry? That's still a monomial.
Oh my word.
A polynomial is separated by the addition sign. So 7y plus something.
Oh.
Any monomial now, another one.
4x.
7y plus 4x is a binomial. Because notice what I have. I have 2 terms. Terms are separated by your plus sign. That's a binomial. Okay? You have 2 terms. If I have 3 terms, I call it a trinomial. Again, the Greek prefix tri means three. Triangle, 3 sides. A tricycle, 3 wheels. Anything with tri in front of it, it's talking about 3, okay? So a trinomial has 3 terms. Give me a trinomial, Eric. Anyone at all that you want. Just make one up. It doesn't have. You're not looking for a specific one.
8x plus 5x plus 10x.
Okay. So Eric has given me. He has given me 3 monomials. However, this is what we're going to learn next. So this is a good segue, good pick. The numeral in each term of a polynomial is called the coefficient. So notice here in the one that Weston gave us, the constant part of the monomial is the coefficient. So notice here my coefficient is 7. Here my coefficient is 4. Okay? Notice my variables are different. So this is as far as I can take this one. 7y plus 4x. That's all you can do. There's nothing more than that. Now notice these 3 monomials that Eric gave me. What are my coefficients here, Desiree? In the 3 monomials that Eric gave me, what are my coefficients? The coefficient is the constant in front of the variables in each term. Nope, that's the variable. But your coefficient is what?
The numbers.
Yeah?
8, 5, and 10.
8, 5, and 10. Now notice something. Up here, in the one that Weston gave us, these are different variables. Again, that's as far as I can go. However, if I have 3 different coefficients, but the same variable expression after the coefficients, namely x, I can combine what we call like terms. Let me see that down here. 2 monomials that are exactly alike, although Eric gave us 3, so I'll just put 3, but 2 or 3 or more, monomials that are exactly alike except for the coefficients. So if everything's exactly the same except the coefficient, they're said to be similar, or like terms. A polynomial is simplified, or in simplest form, when 2 of its terms are similar. All right? So, I'm sorry, when no 2 of its terms. So, in other words, we can add these up. Add 8, 5, and 10 for me, Alex. Add 8, 5, and 10 for me. 23x. So these 3 monomials that Eric gave me are actually the same as 23x, which would be what kind of a polynomial, Alex? 23x is what kind? It's not constant because you have a variable. It is a polynomial, but what kind of polynomial is it? How many terms do you have? 1 term is a monomial. 2 terms, guys, binomial. 3 terms, trinomial. So actually what you gave me, Eric, is you gave me a monomial because you gave me something that will simplify down in simplest terms, or in simplest form, to 23x. So now try to give me another trinomial, this time that can't be simplified. Any trinomial you want.
7y plus 5x plus
13 what?
s.
S? Or you could have just left it at 13. That's fine. Because notice, I can't combine this any further, guys. That's in simplest form. Because I don't have any like variable expressions after my coefficients. So that's a trinomial. Very good. Okay? And then, has everybody got these notes so far, or at least towards the top, so I can scroll a little bit? Okay. All right. So 2 monomials that are exactly alike except for the coefficients are said to be similar or have like terms. A polynomial is simplified, or in simplest form, when no 2 of its terms are similar. So in order, if you get a question that gives you this, they gave you the 3 monomials that Eric gave me, and they say put this in simplest form, this is what they're looking for. They're looking for you to combine the coefficients as long as the variable expressions are all exactly alike. They're like, we call them like terms. Okay? The degree of a variable in a monomial. All right, the degree. And I think I talked a little bit about this yesterday as well. But the degree is the number of times that the variable occurs as a factor in the monomial. So give me a monomial. Hoj. Anyone at all?
3x.
3x. Okay. Now, the degree of the variable in the monomial, 3x, is the number of times that the variable occurs as a factor in the monomial. So what would be my degree be, Katie, of 3x?
X.
What they're asking by a factor is they're saying, what's your exponent of your variable? That's really what they're asking when they say factor. What's my exponent on 3x? What's the exponent on the x? 1. And remember, we don't typically write that, but that's what it is. It's understood that it's 1, okay? This is a first degree monomial. That's all that they're talking about when they're talking about degree. What's the exponent of the variable? That's what they're talking about. The degree of a monomial is the sum of the degrees of its variables. So you could have a monomial with more than one variable, and we did that up at the top. Shay, give me a monomial with more than one variable. Make it interesting with some good exponents. Thanks.
3x squared.
3x squared.
Y cubed.
Y cubed.
C to the 4th power.
C to the 4th power. Wow, look at that. That's a good monomial right there. So, the degree of the monomial is the sum, that means add, of the degrees of its variables. So what's the degree of this monomial, Desiree, that Shay gave us?
Which one?
This is the one she just did here. 3x squared, y cubed, c to the 4th power. What is it? Yes, it's a 9th degree monomial. Because if I added up the degrees of all of my variables, I would get 9. So that's all that they're asking. So when they talk about these things in the book, now remember, for the rest of this chapter, they're going to use these terms. So you have to get your handle on them. If you don't, you're not going to understand these. You're going to get home, you're going to try to do this homework for the next 3, 4, 5 sections, and then farther in the book, and they're going to say degrees and monomials and binomials, and you're not going to know what they're talking about. So you got to make sure you know what this is all about. If I went through it today, and I went through it a little fast, and you don't maybe understand all, remember, we're recording these videos. Go home, take a notebook, read it again. They're also in your book. I take these out of the book. And so you got to know what these are. You can't really move forward. And so just like I told you when I very first took over in chapter 2, when I started with you guys, and the very first lesson we started were all these properties, commutative, associative. And I said to you, if you don't know these, you're going to be lost for the rest of these equations. And some of you didn't believe me, and you didn't go home and study them and put them on flashcards and learn all those, and then you were lost when it came to the quiz. I'm telling you, the first couple lessons here, if you don't know what these terms mean, you're going to be lost. When it tells you to simplify and like terms and combine like terms and all these different things, if you don't know what the vocabulary means, you're not going to get it. So make sure you do that. All right. Finally, the degree of a polynomial is the greatest of the degrees of its terms after it has been simplified. All right. So, Katie, you're going to give me, actually, Nathan, I don't think I've called on you today. Give me a polynomial. And make it interesting for me. Try to impress me. Anyone you want. 25y. Not times, you're going to add. For your polynomials, you're going to add. You use your addition sign.
36x.
36x to the what power?
4.
The 4th power. Oh, okay, awesome. Plus what?
21x.
Let's not use x. Let's use a different variable. T. Okay, that sounds good. What power is the t to?
5th.
The 5th power. Okay. Here is a polynomial. What kind of a polynomial is this, Felix? That Nathan came up with. What kind of polynomial is it?
It's simplified.
It is in simplest form. That's correct. But what else? I'm looking for what type of a polynomial as far as, is it a monomial, a binomial, a trinomial? What do we have? Because you have 3 monomials. Right, you have a trinomial. So, what is the degree of this polynomial? I'm sorry? The degree of the polynomial is the greatest of the degrees of its terms. So, what are the degrees of your, let's write them down. What's the degree, Felix, of this monomial? Just the 25y. What's your degree? Just this first term, your monomial here, 25y. What's your degree of that monomial?
2.
It's always going to be the exponent on your variable. So this is my variable, right? What's my exponent on that y?
There's not.
Which means it's a what? A 1. So this is a first degree. That's a 1 degree. What about this one? What's my degree of 36x to the 4th? 4. And what about this one? 2t to the 5th? 5. And now read the definition again. It says the degree of the polynomial, this whole polynomial, is the greatest of the degrees of its terms after it has been simplified. Well, you guys would agree with me this has been simplified because there's no like terms. If you took away the constants, there's no like terms to simplify. So this is already in simplest form. So it's the degree of the polynomial is the greatest degree of its terms. What's the greatest degree of the terms, Felix? 2t to the 5th. So what degree is that?
5.
So this is a 5th degree polynomial. Okay? All right. We've all got that. I've got 5 minutes left, so let me do a couple examples before I let you go. So let's do some examples. Everyone's on page 148. I'm going to look at number 2. 6m minus 6n minus 4m plus n. And it says copy each polynomial and underline similar terms, as was done in example 1, then simplify the polynomials. All right, so the first thing we're going to do is we're going to underline like terms. Okay? Weston, give me something that I'm going to underline here. So 6m.
6n.
That's not like.
Oh.
You got different variable expressions.
4m.
4 minus 4m. Good. And Tim, what else?
6m and the n.
Okay. And then it says after you underline those, it says simplify the polynomials. Dan, let's simplify. So the blue go together, the red go together. So how am I going to simplify the first one?
Do 6m minus 4.
Which is
2.
2m. Then what?
6n plus n.
Which is,
7.
be careful, minus 6n plus n.
5.
What kind of 5? Plus or minus?
9.
Minus 5n. That's in simplest terms. You can't go any lower than that. So 2n minus 5n. Let me see. Let's go to 3 minutes left. All right, let me do one more here on. Let me do number 14. Negative 2p plus 4q minus 7 minus 4p minus 2q plus 5. And they give the directions as add. Okay? So we're just, guys, we have a few minutes left. So we need to pack up. I want to make sure you know how to do this. These ones are the ones that you're going to have trouble with tonight. So how are we going to add these up? We're just going to do this vertically, okay? So, Hojit, what is minus 2p minus 4p?
Minus 6p.
Desiree, 4q minus 2q.
2q. Negative 2. Positive 2.
And Felix, minus 7 plus 5.
Negative 2.
Okay. And so that's all that they're asking for in these problems. I assigned 2 tough ones at the end just to see who can get them. Don't feel bad if you don't. The rest of them are all pretty much like the ones we did in class. Make sure that you know these terms.